All right, everybody. Hello. Welcome to part 2, tip 2, that was mentioned on the last video. To recall our last video, we gave tip 1, which was the bivariate test key, right? Presented by William O'Bannon of StatsWhisperer. That's me. And the bivariate test key tells us that you choose the correct bivariate test depending on variable structure. Right? And then we have them listed here. This is the original key. So for a categorical variable A and a continuous variable B per se, you would use a t-test. And then we have them on down the line. So the next thing we did was we decided to plug in our variables of interest into the bivariate test key to see what test we would use to figure out some relationships. Now our dependent variable, the variable we wanted to explain, was happiness, right? Happiness. And we wanted to know what's related to happiness. Is owning a pet related to happiness? Is education related to happiness? Is confidence related to happiness? To answer these questions, we needed to plug them in the bivariate test key. So when we take owning a pet, yes, no, and we compare it to happiness, which is continuous, measured on a scale of 1 to 100, we have our two-category variable, and our continuous variable, you would use a t-test. And then on down the line, so we had our categorical variable education, which has more than two categories, and our continuous variable happiness, you would use an ANOVA. If you have two continuous variables, confidence and happiness, a correlation. And finally, just for a proxy, we took our categorical variable education and our categorical variable owning a pet, yes, no. And whenever you have two categoricals, you use a chi-square to do the analysis. So in today's tip, we are going to use the t-test output and the chi-square output for these two tests to present the 20-80% rule in interpreting statistical output. So that brings us to welcome to our new video, tip number 2, the 20-80% rule toward interpreting statistical output, presented by yours truly again of StatsWhisperer. So just exactly what is the 20-80% rule, also known as the Pareto principle? The 20-80% rule states that for many events, approximately 80% of the 80% of the effects come from 20% of the causes. So it's said to have originated with Italian economist Vilfredo Pareto, who observed in 1906 that 80% of the land in Italy was owned by 20% of the population. You'll see this trend in a lot of places, such as business, where you'll see that 80% of your sales come from 20% of your clients. Now, StatsWhisperer suggests in interpreting statistical output that 20% of the values on the output will tell you 80% of the message that statistical test is indicating. The rule can help interpret results quickly and efficiently instead of having one staring at the output aimlessly. So our first example, interpreting our t-test output. So again, recall, we're looking at the relationship between owning a pet and happiness. So if we wanted to make that into a research question, we might say, do people who own a pet report significantly more happiness? So in life, you might get a nice yes or no answer to that, but in statistical software, you get the t-test output below, right? You get two tables with many, many numbers. So somebody says to you, do you own a pet? If you own a pet, does that relate to your level of happiness? And then this is the answer you get. But if you know the critical values to look at, it's almost as simple as a yes or no answer. So C, letter C, that is, the 20%, 80% rule tells us that 20% of the values equal 80% of the message of that test, excuse me. So there are 10 test values per se, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if there's 10 and 20% tell us 80% of the message, there should be 2 key values that'll tell us 80% of the message of that test. So we're looking, is there a significant difference in happiness between people that own pets and don't own pets? So significance, we look at the level of significance. And we know if it's below 0.05, which is the scientific standard, there's a significant difference. So first, number one, the first value, this is below 0.05. So yes, there is a significant difference. So that maybe 40% of the message of the test. So this hasn't been quantified. It's largely conceptual. And then value number two, if there's a significant difference, just who has significantly in higher and lower scores. So we look at the mean. So this is the mean of happiness, right? Happiness mean for who? For the two groups. Do you own a pet? Yes. Do you own a pet? No. And we could see if you own a pet, yes, it's a higher score of happiness, and higher scores indicate more happiness. And the no is 46.0. So value 2 tells us there's higher happiness for owning a pet, which is 73.25, relative to no, not owning a pet, which is 46.0. Perhaps another 40% of the message, right? So from those two values, arguably, we get 80% of the message of that t-test analysis. Right, real quick little tip there. Pardon me. Then we're going to look at our second example, our chi-square output. So if you recall, we wish to examine the relationship between education level and owning a pet. Are you more or less likely to own a pet depending on your level of education, right? So stated in a research question, are people with higher education levels significantly less likely to report owning a pet? Could have been more or less. It's arbitrary. So the research answer, again, are all your numbers and all your tables. So take a look here, because our answer is right in here just by two of these numbers. Now, when I first started doing analysis, I used to stare at these output and just wonder what the heck they were too. And that's where this solution came from. I got tired of staring, which happened pretty quickly. So again, 20, 80% rule. So we're looking at, we have another 10 values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So there should be two key values that'll tell us 80% of the message of the test. So value number one, again, right to the significance. Is there a significant difference? Right? Significance, which is probability P, is less than 0.05, so there is a significant difference. Now, our next question is where is the significant difference, right? So value 2, we're looking at, do you own a pet? Yes. And here are the percentages within education that report owning a pet. So for high school, what percentage own a pet? 75.8. In college, what percentage report own a pet? 60.6. And those who have graduated graduate school, what's the percentage that own a pet? 11.8. So you could see there's a dramatic difference, 11.8 relative to 60.6 is 75.8. So what it's telling us is there's a significant difference between education level and owning a pet, where people who graduated graduate school, a significantly lower proportion, seem to own a pet relative to the education level of college graduate and high school graduate. So G, those two values, arguably, the 20% tell us 80% of the message of that chi-square analysis. Now, the good news is the 20-80% rule, as it relates to interpreting statistical output, relates to ANOVA, right? So if you do an analysis of variance, you have these same key critical numbers that you could find, 2 out of 10. That'll tell you the real crux of the message of the results. Linear regression, same thing. Multiple analysis of variance, binary logistic regression, multinomial logistic regression, etc. All of them have these key critical values that will tell you the 80% of the message of the test. The trick is identifying what those key critical values are. Just what are these 20% of values that are giving you the crux, the 80% of the message of the test. So you can figure that out by yourself, through a friend, through classes, through programs, etc. So the information's there. You just need to figure out just which are the critical numbers. And once you know that, the output becomes rather simple, because you're looking at the key numbers first and then considering the second. You got to look at the other numbers, and you have to know the meanings and the reasons for the other numbers too. But the critical numbers, like if it's not statistically significant, that's the first one you look at, because if it's not, then there's not really much of a reason to look at the other numbers. So there's a hierarchy of these numbers, and that 20% sits at the top. So these materials are from our new 5-week webinar, The Logistics of Statistics, the Process of Data Analysis, which is full of tips. So if you like tip 1 and 2 and want more tips, there's one place to find them. You could look at the details of the webinar at www.statswhisper.com/seminars, So actually, we probably should get a webinar page. So, pardon me. So thank you for tuning in. And as always, more tips can be had by signing up for our newsletter at www.statswhisper.com/newsletter/. Okay, and